When Naughty Dog remade The Last of Us in 2022, gamers and game developers praised it as a true next-gen masterpiece. But everybody was wondering how could this run at 60 FPS on the PS5? The devs at Naughty Dog pulled many tricks using code, math, and clever texture tricks to keep a very high level of quality while respecting a strict budget for performance. To pull this off, these artists established a genius game art pipeline that allowed the game to look this good and fit within a tight memory budget. We will see how they replaced thousands of uniquely baked assets with a single Baked-Bevel Trim Sheet. We will also look at the modular building kits they use to create large environments with a handful of pieces. Finally, we will look into some texturing tricks that allowed them to fake 3D depth using a flat 2D texture. Before we dive into the technical breakdowns, we have to talk about why optimization is so important. Many gamers think running a game at high or cinematic settings at 60 FPS just means buying a more expensive graphic card. But the truth is more complex than that. To hit a steady 60 frames per second, your hardware has exactly 16.6 milliseconds to calculate and draw everything on your screen. If an artist drops an unoptimized hero asset into a scene, three things happen instantly that will hit your frame rate. VRAM usage. High resolution, unique textures fill up your video memory, causing the game to stutter or pop in textures too late. Draw call overload. Every single unique object requires the CPU to tell the GPU to draw it. Too many unique objects create a draw call overload and requires more resources to compute the information. Overdrawn pixels. Complex, heavy shaders like calculating realistic transparent glass panels or complex layering force the hardware to render the same pixel multiple times. If Naughty Dog built this game using a traditional workflow, using plenty of uniquely baked assets, the PS5 build would run much below 60 FPS at 4K on performance mode. Enter the Baked-Bevel Trim Sheet Pipeline. The most impressive trick used in the art pipeline of the game is certainly the Baked-Bevel Trim Sheet. So what is that exactly? Principal artist Matthew Trevelyan Johns is showing us in great details how this technique works. The goal was to create a trim layout that could be shared by the team, a functional replacement pipeline for the many uniquely baked one-to-one assets. Here, we can see how the previous method, uniquely baked assets using a unique normal map, versus this asset using the Baked-Bevel Trim Sheet. Scale that to 100, if not thousands of assets, and you can understand how much was saved on the texture memory. We can see the full process here. The artist carefully measured a set of high poly panels mapped at 512 pixels per meter. These sizes would fit most faces of their small props. The artist used Substance Designer to create a template material that would allow the team to plug in tileable textures and have all the edgeware and texture details as well as blend masks created for them, with room for additional tweaking. Here's an example of a metal material. These models are all hard-edged with no bevel, allowing the bevel details to come entirely from the normal map. And here's a tintable plastic material. The models themselves all need hard edges and 90-degree angles for the baked bevel trims to function properly. This allows the team to bevel less and make additional polygon saving. Now here's an amazing tool developed by the artist, the tech team, as well as the team at SideFX Labs. We can see that the window frame has no correct UVs, only basic UV shells. In a few clicks, the UV shells have been correctly aligned to their corresponding area. The tool has many more options, but simply with this, you can clearly see how much this would speed up their workflow. So there you have it. This is the work of a principal artist on a AAA production. The role requires to think ahead of a production's need and research, experiment, and document workflows and pipelines that will make the lives of the whole team much easier for the next few years of production. Next, we move on to one of the staples of modern environment art techniques, the modular kits. Let's look into the work of senior environment artist Nestor Carpintero. This is the University Plaza Yard building tilesets. The modular tilesets, or kits, were created and assembled by the artist, while the materials were made by senior environment artist Peyton Varney. We are very lucky to be able to see the kits, the models with wireframes in Maya, the models with materials and vertex painting still in Maya, and finally, in the game engine to see the final version in all its glory with set dressing, foliage, lighting, and post-process. Now let's look at the interior tilesets for the University Plaza Yard library. Still by the same artists, we can see the same elements in the breakdown. So the tilesets, the wireframes, and the version with material and vertex painting, so we can appreciate the vertex density that they use for blending their different materials together. We also have a furniture kit that is mainly using the Baked-Bevel Trim workflow seen earlier. And finally, the version that ended up in the game engine. If you're learning from these videos but are still struggling to put everything together into a full environment, that's exactly why I built my full course. You'll build the entire scene step by step in real time, understanding composition, scale, materials, and lighting, so you can apply the same process to your own worlds. These environments were created by students using the same workflow you will learn here. It's designed for artists who already know the basics and want to create a professional portfolio work, not just isolated studies. This isn't about learning tools, it's about learning how professionals build environments. If that's where you're trying to get to, you can check the link in the description. Next up, we will discuss the work of senior environment texture artist Jonathan Benainos. So this is the Capitol Building Materials Showcase. Every material were all fully created in Substance Designer, and the material balls were rendered in Marmoset Toolbag. While these materials were made for the Capitol exterior, most of them were also put in the base library and can be found throughout the game. Here is a reference board of the Massachusetts State House on the right and the final building in the game on the left. After creating the shader in a proprietary software, the artist is blending the different layered materials using vertex color in Maya. It allows him to add cracks, moss, leaks, and wetness to the arches. Now onto the material and asset breakdown of the gate and railing. Modeled in Maya and textured with Substance Designer, the only geometry here is the frame of the door and the handrail. The rest is a texture made with Substance Designer. Here, the artist used an opacity mask and height map combined with some parallax occlusion mapping in the shader to fake the thickness of the ornate details. The only geometry here is the frame of the gate. Here, we can see another video showcasing the shader and blending work done on the walls outside of the Capitol building. Each RGB channel of the vertex color setup allows the artist to paint different texture sets from the material library. So with a team of several artists, you can understand how having a very well organized shader library is important. This will be one of the topics of my upcoming courses that will be announced soon. I'm happy to introduce a new partner of the channel, Bundle Foundry. You can get several tutorials for a very good price here. The current bundle that is still available is called Become a 3D Artist Mega Tutorial Bundle. Several bundles just launched. You want to check this out. Check out the price also. This is great value. This is a great opportunity to level up your skills at a great price. Links to the bundles will be in the description. When playing a game like The Last of Us Part 1, it's easy to get fully immersed in the environments and get lost in the beauty of its world. But as we've seen today, the magic of the highest level of AAA video game art isn't about who can sculpt the most realistic rock or who can create the best brick material. What matters for working in a studio like Naughty Dog is the knowledge of the systems of environment art and its fundamentals. You have to be more than a game artist. You have to be a problem solver working in an environment full of constraints and technical issues that will be in your way. This is the reality of working in any studio. It requires collaboration and communication. This kind of attitude is what recruiters are looking for when they ask candidates questions during an interview. You will not only be working on your dedicated tasks, you will be called to help others with their problems and bugs, and you will have to be creative and think for yourself. So the sooner you learn about how games are made as a whole, or at least how game art is all interconnected, the better. This will show during interviews, and teams will want someone like you on board. I'm also offering a AAA portfolio checklist that might help you figure out what's important for employers when applying for a job. The link is in the description. And a quick thank you to the members supporting the channel. Your support helps make these videos possible.